Okay, so we're going to go through an example of assessing the qualities of a screening test. And so here's our problem. Cystic fibrosis, or CF, is a genetic disorder passed down through families. CF causes thick mucus to build up in the lungs and can lead to breathing and digestive problems and life-threatening infections. Early diagnosis at birth can help to reduce the health risks associated with CF and improve projected lifespan and quality of life. Newborn babies are commonly tested for CF by a blood test. However, a screening test that does not involve a blood sample is available. To reduce the pain of blood drawing, you want to evaluate the sensitivity and specificity of the new test, which is non-invasive and relies on a sweat sample. Let's assume that the existing blood test is the gold standard for CF and that the prevalence of CF among newborns in the U.S. is approximately 1 in 350. With the cooperation of hospitals in Pennsylvania, you would administer the sweat screening test to all 145,000 babies born in Pennsylvania this year and obtain the following results. Okay, so here's our table. It's already filled in for us, which is great. So the first question is, of those testing positive, in how many will the results be truly positive, and in how many will they be falsely positive? Okay, so this is asking a very simple question. Among those who test positive, so that is this row. So the question is how many will be truly positive. So that's a true positive. And we know that cell is 406. Actually, I'm going to change my color here. Because this cell is the people who are CF positive and who screen positive. And then we want to know how many are falsely positive. So our false positives is this cell, 7229. Those are people who are not positive for CF, but who screened positive. Get rid of all that for our next question. Okay. And then we want to know, among those testing negative, for how many babies will the test be truly negative, and for how many will be falsely negative? Again, so this is simple. We're just going to look at our negative row. And so we know our true negatives are 1, 3, 7, 3, 5, 6. Those are ones who tested negative and who actually are negative. Our false negatives is 8. So those are who actually are CF positive, but who screened negative. So the purpose of these first two questions was really just to get you comfortable with the table and make sure you understand that there are 4 possibilities, right? True negative, true positive, false negative, false positive. Okay, so let's move on. So calculate the sensitivity. So the sensitivity, right, is going to be, it's our true positives divided by basically all those who are positive in reality. So those are our true positives plus, sorry, I shouldn't use positive twice that way, are false negatives. Another way to think about this, if you want to think about our 2 by 2 tables and the numbers we commonly use, it would be A over A plus C. Okay, I know you can't see the table as I get farther and farther away. Okay, so sensitivity then is 406 divided by 414. This equals 98.1%. And the sentence that goes along with this is that among those babies that have CF, 98.1% of them will be accurately detected by our screening test. We can then, oh wait, I have to go to my next page, calculate our specificity. And I know, so now the table's not on this page, so if you want to go back a second in the video and write down the table on like a scrap of paper next to this, and then you can follow along with these questions. Okay, so specificity. So specificity, if we want to think about that, are true negatives divided by our true negatives plus our false positives. So basically, these are all people who are actually negative, but they may or may not have tested negative in the screening test. If we want to think about our 2 by 2 table with our common A, D, B, or A, B, C, D, this would be D over B plus D. Okay, so let's calculate. So if you can see the table, if you copied it down, the numbers here are 137,356 divided by 144,586. I'm missing a letter there, but you know what I mean. And this equals 95%. So when we're talking about specificity, what this means is that among those babies who are truly CF negative, 95% of them will be accurately detected by our screening test. And now for question 5, we're asking about the positive predictive value. So remember, I think about sensitivity and specificity as going up and down the columns. Positive and negative predictive value are going across the rows. And what positive predictive value is our true positives divided by our true positives plus our false positive. Basically, our denominator is everyone who screened positive for the test. And the numbers here, if you would be able to look at our table, is 406 divided by 7635, which equals 0.05 or 5%. So basically what this means in words is that among those who screen positive, 5% of them actually have CF. So that's a really low positive predictive value. So let's overall, in the calculations we've done so far, very high sensitivity. It's accurately capturing those who truly have CF. Fairly high specificity. It's accurately capturing those who are negative, but a low positive predictive value. So there's going to be a lot of people who screen, a lot of babies who screen positive who don't actually have CF. So what are the pros and cons of this screening test? So we have high sensitivity. It's doing a really good job. We don't have many babies. As a matter of fact, I think we had just 8 babies who truly had CF, but were not found by this screening test. We have low sensitivity, or specificity, let's erase that. We also have high specificity. Again, so babies who are really negative are screened as negative. So this again is all really good. The issue, right, is the low positive predictive value. And so what that means is that you're going to get a lot of babies who are going to, there's going to be a lot of babies who screen positive for this test who then need to go on to the gold standard test and they will be negative. So let's discuss just quickly the pros and cons of, any screening test, right? So we want a screening test that has high sensitivity. We do not want babies going home thinking that they're fine when they're really sick. So in this case, with our high sensitivity, we're not going to have babies go home, a whole lot of babies go home thinking they're fine and actually be sick. We also have high specificity, so it's not missing a lot of the negatives. The problem with the low positive predictive value from a pro and con point of view is that you're going to have a lot of people, a lot of parents with really high anxiety because they're going to test, their babies are going to test positive and then they're going to have to go back, right? So the pros and cons of any screening test are you want to catch people, you want to make sure you detect illness, especially if it's a really serious illness that we can intervene on early. You want to be able to catch all those people, but then you don't want to incorrectly catch people and raise their anxiety, waste time on medical tests that may not be necessary. So those are always the things you need to think about and really think about, how severe is this disease and is it worth having a lot of false positives and get those people into diagnosis earlier or a diagnostic exam earlier because it's so serious and because you want to capture it quickly and get treatment started quickly or, some other efforts started quickly. Or perhaps it's, a less serious illness and it's okay to let a few people who actually are positive go because you'd rather have that happen and have, lower anxiety so you don't have a lot of people testing positive who aren't actually positive. So those are always the things we weigh in a screening test.